zone is modeled by the function where t is in months and t equals 1 corresponds to 1st of January. Find the 1st of May. Okay, so if t equals 1 is 1st of Jan, then 1st of May will be t equals 5. So we're going to substitute that value in. So A is 210 sine 0.5 times 5 minus 2.6 plus 990. Oh look, here I've got up here, what have I done here? There we go, so that is 969. Okay, B, find the rate of change of the deer population. Okay, so rate of change indicates that we're going to be differentiating it. Oh, I should have said, made sure here that we are in radians. Make sure your calculator is in radians, because these will be radians, not degrees. And it's an application question. Alright, so B part 1, rate of change. So rate of change indicates that we're going to be finding the derivative. So let's get that in sight. Okay, so we've got sine, just so you remember, if you're not sure, derivative of sine goes to cos. Let's snip that. Obviously we've got a few extra things that we need to deal with here. So we've got 210 cos of 0.5 t minus 2.6 plus nothing. Because the 990 differentiates to be nothing. But it wasn't just sine of x, or it was sine of 0.5 t minus 0.6. And remember, derivatives, we then multiply by the derivative of what was inside the bracket. So that in this case is 0.5. So we have 105 cos of 0.5 t minus 2.6. So there's our derivative. 1st of May, so obviously t is still 5 for that value. So we're finding p dash 5. So, was it 105? 105. Checking my radians up here. 105 cos 0.5 times 5 minus 2.6. .5 0.5 times 5 minus 2.6. What's gone wrong here? Oh, 0.05. Oh, 105 cos 0.5 times 5 minus 2.6. Because I know it can't be a negative value. There we go, 104. Okay, interpret the answer, excuse me, with reference to the deer population size on 1st of May. Okay, so since the derivative is positive, that would say that the deer population size is increasing. Because remember, the rate of change talks about the gradient. So the rate of change is positive, so therefore it must be an increasing population. Okay. Okay, so the velocity is given by that. Pareto, whose displacement is that when t is 0, both at the same point. Find Ramiro's displacement. Okay, so at the moment we've been given a velocity expression for Ramiro, so that if we want to find his displacement, that means we need to integrate. Remember, this is a kinematics question. So, let's go. S of Ramiro is going to be the integral of the velocity, which is 40 minus t squared dt, which is 40t minus t cubed over 3 plus c. Right, so we now need to find c. Okay, when t equals 0, both values are at the same point, so we need to find Lorito's position. So, SL equals 2t squared plus 6t. When t equals 0, SL equals 2 times 0 squared plus 6t equals 60. So that means that 40 times 0 minus 0 cubed over 3 plus c has to equal 60, which means that c is 60, so that S of Ramiro is now 40t minus t cubed over 3 plus 60. So there's an expression for Ramiro. We want to find his displacement when t is 10, so we're going to stick 10 into there. Okay. Oh, I can't see it now. 40 times 10 minus 10 cubed over 3 plus 60. Let's change that to decimal. Is 126.6 recurring, or 126 2/3, or rounding that to 3 significance 127. So that's right, 126 2/3 meters, or 127 to 3 sig fig.